Hello, everyone. Good afternoon, perhaps good evening for some. It's good morning for me still. Pleasure, though, to be here for virtual ZeveCon. Not as nice as being in Gdynia, but we will take what we can get given current circumstances. So to close out the day for ZeveCon, we'll talk about something that I've been thinking about for almost exactly a year now on cyber consequences in the perspective of operational dependencies and how this applies to security beyond the scope that we typically apply of just networks or just focusing on the IT assets within an organization. So first, who am I? My name is Joseph Slowik, if you actually pronounce it properly in Polish, as opposed to how pronounce it in the United States. But currently I work for a company called Drigos, where I do threat intelligence work with an emphasis on industrial control systems. And in fact, many of the examples that we'll talk about today are industrial in nature, which will be fairly obvious why that is when you start talking about chains of consequences and how that plays out in terms of physical responses. And also, prior to that, I led the incident response team at Los Alamos National Laboratory and was an officer in the U.S. Navy prior to that. But enough about me. Really, this talk came about with an event that happened exactly a year ago today, maybe the 13th of September, depending on time zones, but at least it was reported in the U.S. press on the 14th of September last year in 2019 of a drone and missile strike on a oil and gas facility or several oil and gas facilities in Saudi Arabia, including a massive oil processing facility at in a location called Abqaiq, which is responsible for hydrodesulfurization of sour crude oil. Essentially, the Abqaiq facility allows for the further refinement of produced crude oil so that it is acceptable to markets for importation. Now, if you look at the overall strategic picture within Saudi Arabia, the Abqaiq facility has been sort of the nasty little secret of the Saudi oil industry for quite some time, in that the majority of Saudi oil exportation is dependent upon the refinement at Abqaiq in order for oil to be suitable for exportation. Basically, if that facility doesn't exist or if that facility is damaged, such as through a drone or missile strike, the entire industry grinds to a halt. And in fact, that's kind of what happened for several weeks, if not several months, as that facility was being repaired, that the Saudis needed, or at least Saudi Aramco had to dip into reserves in order to meet previous demand. So that really shows that there's a sort of a critical dependency here that, in order to impact a much bigger process, the entire oil and gas industry in Saudi Arabia, really you can target only one specific facility, and even then only very specific aspects of that facility in order to have outsized results. Now, you may be asking yourself right now, wait a minute, this is a cyber conference. This is red versus blue. We should be talking about information security. Where the hell's the cyber? Well, the cyber is there because concurrently with this event, roughly concurrently, certainly from late 2018 through multiple events in 2019, including a few that took place shortly after the physical attack on the Abqaiq facility, there had been multiple rounds of disruptive malware attacks or incidents on the oil and gas sector in Saudi Arabia, as well as in other areas of the Gulf. So really what we're seeing, or how we can categorize the Abqaiq strike, is really as one part of a broader set of efforts or designs to try and disrupt one of the main economic engines of this region, and as efforts tied to Iranian strategic interests. So what we're seeing is not just a example of what cyber can do, but really looking into a greater degree, or to a more in-depth degree, of adversaries have goals, and those goals don't necessarily need to be met by cyber, but the way in which modern systems and complex nature of things like the Saudi oil and gas industry operate mean that we can start looking at really specific ways of targeting these establishments or these organizations so that relatively small or focused impacts can have outsized influence, resulting in much broader dislocation than just the immediate impact of whatever is initially targeted. And looking at some of the wiper events, we haven't quite gotten there yet, but in light of things like the Abkhaz strike, it seems that adversaries are starting to get smarter in terms of what they're targeting and what certain weaknesses or Achilles heels may exist within these entities. So the takeaway is that attackers ultimately care about causing disruption of some sort, and complex systems like a nationwide oil and gas industry largely operated by a single organization really yield specific pain points that can allow for outsized impact if those weak points are first identified and then exploited or disrupted in some way, which gets us back to the cybers. So our agenda today, after this lengthy introduction, is we'll talk about process and operational dependencies and how this loops back into information systems, and then look at, in very brief fashion, some targeted disruptive attacks that focus on this concept of dependencies or critical path dependencies for how things are executed and what sort of implications and risks those dependencies have. And then we'll conclude by talking about, well, what do we do about this? How do we defend against this? And how can we embrace or take into consideration concepts like offensive security in trying to cover or to mitigate against these type of risks? And finally close with some future expectations for what we might expect within this space. So first, process complexity. This is a screenshot from modeling software produced by Rockwell. It's called Arena. At least I think it's still produced by Rockwell. But this is just a very simple example of how to model a complex, in this case, it's a shipping process. And as we can see here, and this is no different than looking at things like program UML or program design language of how we can start laying out operations from the very start or inputs into a process all the way to its end, and seeing the different decision gates or the different requirements as, whether you're talking about manufacturing as widgets move along the line of the different necessary stages that the widget needs to go through until it is finalized or production is complete. Well, the thing is that process complexity means that we have an ever greater number of potential touch points where that process can be disrupted. That if a certain process node is removed or degraded in some way, the entire process as a whole can grind to a halt, which gets us into the concept of process dependencies. So typically we look at these in terms of critical path nodes as they come in terms of timing, that the sort of deltas or the differences between the earliest and latest start and finish times for something and how that gets sorted out to identify what are the stages that will be the determining items for how long a process will take. Well, the same sort of concept applies when we start looking, again, going back to process complexity, that if we have something like a hydrodesulfurization facility that is required for oil and gas production, that becomes a critical path node for the entire process to function. So while there may be certain things that, yes, if this is delayed or degraded in some way, we can work around that in some way, or the amount of time required to bring that specific piece of the process back up and running again is something that we can absorb because we're waiting on other things to get taken care of in the meantime. There are other items that we simply can't do without that form a critical path node for the overall process, that if those are disrupted, then the entire process is impacted in some fashion. And we see this building up as we get into ever more complex and ever more distributed sort of processes that have multiple dependencies. These can be dependencies on external suppliers. They can be dependencies on external infrastructure, think the cloud, which we'll get into in a second, and other items that can allow for operational disruption to be simplified. I mean, it's kind of funny that we talk about greater complexity on the one hand, leading to a simplification of cyber attacks or even just attacks in general on the other. But the ultimate takeaway from this is that in order to adequately defend or build in resiliency to these sorts of networks, whether we're talking about industrial processes or even things like elections or the financial system, we need to understand the nature of the operation and what those critical path nodes are, or what those most important or most significant aspects of the overall process might be that can lead to outsized impacts should an attacker hold that at risk. And we see this in modern operations through things like complex supply chains, as well as an emphasis from a business perspective of things like just-in-time production and inventory minimization, the so-called Toyota production system or method of thinking that many organizations, whether you're talking logistics like at Amazon or manufacturing like a Toyota or most other automotive manufacturers, of not having lots of spare parts on hand because it costs money, and we want to save money and make things as most efficient as possible. Well, the problem is in getting after these efficiencies or trying to diversify supply chains is that it starts extending out the potentials for disrupting the process itself and introducing the capability or enhancing the capability of an attacker to hold that at risk. And we see this extending into digitalization, whether you're talking about something within industrial controls like the so-called fourth industrial revolution, where we start integrating things like cloud computing and increased adoption of information systems and physical environments, such that items that previously would have been only vulnerable or only accessible through physical means or some other fashion are now network reachable, allowing for attackers to potentially influence processes or touch or manipulate processes that wouldn't have been accessible previously, exposing the vulnerable or the critical systems to potential attack. And we see this even getting away from very industrial examples into just general information processing, where we talk about organizations minimizing risks through adoption of the cloud or adoption of managed service providers. But as we've seen, when things like a Cloudflare goes down, or there's a massive power outage or network, whether physical or logical network routing incident that might impact the Northern Virginia region in the United States, which happens to be where the EC2 instance for AWS East is located, that has magnified effects that then all those organizations that were dependent upon those resources are now impacted because they had relied upon that being there no matter what, and now are impacted through the loss of that supposed resiliency that had been built out through a third party. Okay, so that's enough about talking, lots of business examples and other sorts of things. Maybe it's a little boring for those who are just closing up a day of multiple talks. How does this actually apply to attacks? And I always like throwing the Norse map out here because we could all point and laugh at this because they're no longer around to defend themselves. But anyway, have we actually seen this in practice? And the answer is yes. And not just in talking about someone launching missiles at an oil and gas processing facility. We've seen this going back quite far. And to try to limit the discussion, I'm only going to talk about 5 or 6 examples today, but the first one goes back 6 years. In Ukraine in 2014, during the country's presidential elections, there were a series of network intrusions linked to Cyber Berkut, which is assessed by many to be linked to Russian strategic interests. You can actually read about that in depth in, I saw it mentioned earlier, with Tom Ridd's book that it comes up in there. But anyway, getting back to the Ukraine example, what was interesting about this is that the defenders in question did a good job in remediating and recovering from this attack. That it looked like the attackers were trying to take down various election infrastructure and inhibit the ability of the Ukrainian state to announce results and to provide feedback in the aftermath of the election. Well, the thing is, though, is that there was a critical dependency that the immediate defenders didn't have control over, which provided for a very interesting attack pattern. And while this didn't exactly work as intended, because the defenders in Ukraine did a good job in responding to the initial attacks, what this event highlighted was a really interesting way in which the media served as a critical external dependency for the Ukrainian election results, such that the way the attack was designed was to try to interrupt the ability of the Ukrainian government to broadcast official results, and then to throw up fake results that could then be amplified, retweeted, however you want to phrase it, by malicious authorities, and in this case by Russian state media, in order to increase uncertainty and cause a certain degree of instability surrounding the entire electoral process. And the thing is that as good of a job as the defenders did in defending the election authority networks, they didn't have control over this media aspect. And had this attack been a shade more successful, the attackers would have been, or the defenders would have been in a bind in not being able to, or not having the foresight to extend their response to include things like, oh, do we have the ability to try to control or manage the narrative for what is going on and how results may be broadcast after the fact, and might an attacker take advantage of this? Keeping on the Ukrainian theme, the very next year, in 2015, we saw the first cyber nexus, or the first publicly known, at least, cyber nexus manipulation of the electric system, with a attack linked to the sandworm entity that resulted in the disruption of electric distribution operations across several sites within Ukraine for several hours. What was interesting about this attack, though, is that it wasn't just a question of turning off the lights, so to speak, but rather it was a attack that went to pains to target process recovery, looking at the specific functions within the electricity management, or especially on the distribution level, managing on the distribution yards, of what would the operators need to restore operations after opening breakers within the affected facilities. So really, the electric disruption was just the first stage of a multi-stage attack that included afterwards blocking serial to Ethernet converters that would allow for logical commands from the control center to go down to the switching yards, by basically bricking those devices to prevent communication. And then, to make things even worse, corrupting the uninterruptible power supplies within the control rooms, so that the backup power, when primary power was lost because of the electric disruption, backup power was also lost. And then finally wiping the operator workstations with kill disk malware to produce a loss of view over the environment, in addition to the loss of power and the inability to send commands to the physical equipment. So overall, what the attackers realized or attempted to achieve in 2015 was not just interrupting the supply of power, but sort of blowing the bridges behind them by understanding the processes necessary in order to facilitate operational recovery to prolong that disruption as long as possible. Well, in this case, the Ukrainians, and again, the Ukraine has been the victim of so many things, and overall they've done a really good job in trying to keep pace with these under very, very distressing circumstances, not to mention having a portion of their country basically invaded. But in 2015, the operators were able to restore electricity fairly quickly because they rapidly transitioned into manual operations, so that they avoided all of the dislocation produced by these recovery targeting aspects of the attack. If it happened in Western Europe, or if this had happened in the United States, or Poland for that matter, in parts of the electric system that I'm familiar with that are rapidly modernizing, this attack would have been far more disruptive, because there's a greater reliance on having remote connectivity and remote control over these facilities, whereas the Ukrainians were able to spin up personnel on site quite quickly to restore operations. Well, what's interesting is that in 2016, again in Ukraine, we had another power event that indicated, at least after some further analysis, that attackers had taken into consideration. So the initial takeaway from 2016 in Ukraine was malware that was responsible for manipulating the electric system. Indestroyer, as named by ESET, Crash Override, as named by Dragos. This resulted in a slightly smaller electric disruption with a quicker recovery time. And so at first it seemed like this attack might be less severe, but further review indicated actually a much more significant attack that was looking at process protection, and specifically the criticality of protective relays as a critical component in ensuring the safety and protection of electrical equipment to try to induce a actual destructive attack within the targeted transmission station. Because in this attack, it looked like the attackers anticipated the rush to physical restoration, because after inducing the transmission outage, the attackers then basically deployed somewhat similar techniques in order to disrupt recovery, but in this case, added on an additional stage to this attack by executing a denial of service on a digital protective relay within the environment that removed line protection from the electric system, such that if the system had been reconnected with the denial of service having taken place, then the system would have been in an unprotected state on restoration, leading to the possibility of things like either an overcurrent condition or the possibility that natural fluctuations within the overall electric environment could propagate beyond the process protection in place to cause physical damage to the electrical equipment at the transmission station, which would have been a much costlier or much more significant attack. Fortunately, the attackers screwed a lot of things up in this attack. There's a paper that I wrote on this if anyone is interested in diving into this in some detail. It's also included in the references at the end of this talk. But overall, the takeaway from this is that the attackers are learning from events over time and getting more aggressive and more ambitious in what it is they're trying to targeting by looking at focal points within the overall system and identifying what are those critical touch points that could allow for maximization of not just disruption, but in the 2016 Ukraine example, even potentially physical destruction as well. Moving on to Saudi Arabia, we had the Triton Trisis event, which was an oil and gas facility within Saudi Arabia. So it might sound very similar to the Abqaiq attack, although this is more likely linked to Russian state interest than it is Iran. That's kind of an open question and really beside the point for what we're discussing here. But what was interesting about this industrial-focused attack was this was a safety-specific attack, that the attackers realized that in order to try to disrupt operations within an oil and gas facility, they needed to pair an intrusion into the plant distributed control system network that controls the physical process itself within the oil and gas facility with a compromise of the plant's safety network as well. This led to the Triton Trisis malware, which enabled a undetected arbitrary modification of safety setting and worked properly. The takeaway here is that the malware didn't work, which resulted in the safety system tripping. So it led to an immediate plant shutdown instead of putting the plant in an unsafe state, leading to the potential for causing physical disruption later on. The main takeaway here, though, is that even though the attackers, again, failed to try to execute the attack as likely intended, and there's a couple of papers I have linked at the end of this presentation that go into this in further detail, this also shows that attackers are understanding the interconnected nature of certain industrial processes, that in order to have a cyber-focused impact on a oil and gas environment, that it's not sufficient to just modify the settings within the production network, because those changes or any sort of consequences from them will be caught by things like the plant safety network or the various safety instrumented systems that are deployed as part of the plant setup. So instead, you need to target that safety network in order to remove that layer of protection to allow attacks to propagate beyond where they would be caught and potentially mitigated by plant safety systems in order to enable a potential destructive attack. So I've picked on Ukraine a lot, and we've talked about Saudi Arabia, but these aren't just events that are limited to places that may be somewhat similar to active conflict zones. Instead, we're actually seeing this in places like the United States as well. There was an event in 2018 that was somewhat overlooked, where a company that is responsible for essentially data analysis and data collection for pipeline operations was compromised in such a way that it impacted the ability of that company to perform its role in managing pipeline-related data for managing inventory, tracking shipments, billing, etc. And the result is that the pipeline system, while it could physically operate, because operations were reliant on the data aggregation and analysis of this particular software suite, that operations were significantly impaired for a period of time while the organization worked to recover from that incident. So the ERP software in question enables pipeline transfer operations by tracking resources and billing. Seems like fairly mundane things, but if you can't adequately bill for material that's flowing through your pipeline network, or you can't even track the amount of material flowing through the network, it's really hard to operate in an accurate or sustainable fashion. And by disabling or modifying that ERP, which does not appear to have been the case in this attack, but is a possibility that may have occurred as a result of this sort of an intrusion, an attacker could significantly reduce the operational effectiveness and integrity of the system in question, such that even though the physical pipeline network would still be okay, you could still pump gas, oil, water, whatever it is, chemicals that are flowing through the pipeline network. From a sort of logical perspective, removing the ERP functionality results in an inability to adequately control and monitor that process, so that you can no longer operate the pipeline, even though the physical pipeline integrity is still there. So there's one key component, which is also network facing as opposed to air gapped or isolated, happens to be a Achilles heel for potentially impacting the entire pipeline system. Finally, last example, thank you for bearing with me so far. Also in the United States, at the end of 2019, we had another incident impacting pipelines where ransomware, by impacting the IT environment linked to a pipeline operator, resulted in that pipeline having to shut down for a period of time, because even though, again, the pipeline itself was not impacted directly by this event whatsoever, the ability to gain visibility into and operational control over the pipeline was inhibited by losing IT-based assets. So again, we're having a physical impact, the loss of pipeline operations in such a way that then resulted in further follow-on disruption, not just to the pipeline itself, but to all of those consumers of the resources move through that pipeline, because, kind of like we've talked about earlier in terms of things like inventory minimization and an emphasis on just-in-time operations, most often when it comes to things like pipeline networks, you don't necessarily have large surpluses or large inventories of whatever is flowing through that pipeline, but instead are relying on just-in-time or continuous operations in order to continue natural gas, electricity generation, chemical plant manufacturing, etc. In the case of something like this event, where we could use ransomware in order to remove IT visibility over a pipeline network to a pipeline shutdown, we can basically disrupt the pipeline without ever physically impacting the operation of the pipeline itself, such that we can undermine the entire system and then lead to physical process, maybe not disruption outright, but certainly process interruption that can result in the lack of ability or the inability of downstream customers to operate anymore. All as the result of something that's purely IT focused without having any bit of ICS magical understanding or whatnot whatsoever. Okay, so lots of examples, lots of possibilities here. What does this mean? Well, for defenders, that means that we're very comfortable defending or monitoring IT networks. We're very comfortable pen testing these networks or performing risk calculations for these networks. But the thing is that network defense, as we typically apply it, is usually blind to or agnostic to the actual business processes or organizational principles that the network itself exists to operate. Adversaries, however, are really only focused at the end of the day of delivering some sort of effect. And the network may just be a means to an end for the adversary, and rather their ultimate goal is trying to achieve some disruption or dislocation for the underlying organization, whatever it is that the organization does to generate value. Because we look at the attacker mindset, Adversaries have goals. Their goal is to make money. Their goal is to disrupt Ukraine. Their goal is to disrupt the United States or Poland or something else along those lines. Well, the nature of that goal, shutting down the electricity, manipulating the financial system or whatnot, is going to determine what type of attack. Cyber attacks just happen to be fairly easy, easy to execute remotely, fairly cheaply to perform instead of throwing bombs at someone and whatnot. And so they're just really a means to achieve whatever it is the attacker wants out of this entire process. By identifying the routes to the goals, or the various touch points to achieve these goals, shutting down the electricity, shutting down a pipeline, manipulating election results, attackers can then start figuring out, okay, based upon what I'm trying to achieve, what is the easiest, simplest way of trying to do this, and achieve some sense of mission success. Because ultimately, attackers don't get judged on how complex or fancy their attack is. They really just get judged on whether or not they achieve what they were instructed to do. That's what gets them medals or allows them to pay out from a ransomware event and whatnot. Well, looking at this is that network defense needs to adopt a mindset where we're not just focusing on the network as a value in itself, but rather the network is just a means to an end. The network allows the organization to continue producing value, generating value, or not losing value for the organization. So if we really want to start looking at the various dependencies that play out in terms of how organizations are built currently, as defenders, we need to adopt a mindset that's similar to attackers, where the network is just a very accessible or easily manipulated touch point that attackers can use in order to cause further on value disruption. And by adopting this mindset of value defense for the organization, we can gain greater perspective of what are the important things within our own networks that we need to defend, and what are the external dependencies or the sort of unlooked for cascade of consequences that might exist from certain attack vectors, so that we don't get surprised by things such as, like we saw in the 2014 case in Ukraine, where we could do our jobs quite well, but because of a forgotten or unlooked for external dependency, such as relying on the media in order to broadcast results, that attackers can use that external dependency as a way to get around our own internal successes to still achieve or potentially achieve their own goals. We need to start mapping through and understanding and extending where we can either our preventative defense, or at least building in mitigations and resiliency to try and meet and overcome these sorts of scenarios. So really what we're looking for here is a type of full scope defense, where first we want to understand the organization itself. Then we want to start mapping defense to the process and organizational dependencies within our environments, and build out detections, resilience, and recovery to match the possibilities for disrupting key sources of value in our environment. So the very first step in all this, and this might seem trivial, but it's pretty significant, is that we need to identify what is it about the organizations we work in that generate value. Whether we are providing network defense for a university, for a global manufacturer, or for a bank, what is it that allows our organization to continue to function? This very simply could be monetary. How does the organization make or not lose money? And what are the sources of value generation within the environment? But that extends a little bit further into sort of functional values, such as what processes does the organization rely on in order to generate value? Based on that, we can then start mapping out what are the sort of critical nodes necessary in order to ensure that processes remain functional. This could be something like looking at the backbone Swift software that allows for interbank transfers, for example, that if that doesn't exist, the entire financial system grinds to a halt. Maybe we want to make sure that we build in resiliency or some understanding for how we ensure that these sort of plumbing between organizations does not get disrupted, so that we don't get essentially a functional kill on the business through something that we otherwise were ignoring or not bothering to control. And lastly, and this is kind of interesting as well, and somewhat difficult to try and defend against, but very important to keep in mind, there's also the question of reputation or optics. When it comes to disruptions, intrusions, and other activities, what type of disruption can an organization actually withstand? Can we have something like acceptable losses, or are there certain things that even any sort of intrusion, any loss of data, or any disruption whatsoever results in too significant of a reputational hit that we must avoid at all costs? So based on that, we could look at examples such as when evaluating different resources within our networks. Not every resource is equivalently valuable. So we certainly know that things like domain controllers are critically valuable for the sake of network operations. But it may be that we also have servers or workstations in our environment that are also fundamentally valued because they control fundamental aspects of the business in such a fashion that if that workstation or that server is corrupted, disrupted, or data from it is lost, we are undermining the ability of the organization to function properly, such that we need to defend that at all costs. Whereas some random workstation in accounting or HR, while we don't want that to be compromised, if it gets hit with ransomware, it's fine because we can recover that machine without negatively impacting the overall value proposition of the organization. So really looking at a function-based or functional level of defense that is tied to different aspects of where it is the organization generates and maintains value. Next, figure out how that overlaps with the cybers. So what information systems map to those critical value sources? This could include things like where the design models are kept for a manufacturing environment, or where the trading algorithms are housed for a financial services company, or where the key intellectual property is located for any sort of research and development organization. And then figuring out what IT capabilities are necessary in order to continue and facilitate that value generation. Finally, then figure out, does your defensive capability and IT visibility extend to these critical assets? This is where the industrial control perspective becomes quite handy, because what we often see is that critical sources of organizational value, like the actual production environments that enable a manufacturer to exist and to do their jobs, lack the sort of visibility necessary to adequately defend and monitor those environments, whereas different parts of the network that aren't really vital to the existence of the organization, like all the computers in HR, for example, they're important, but if they go away, the business can still function. If the plant floor network goes down, though, production ceases, the organization begins losing lots of money. Yet we expend lots of effort on building out defense for these non-vital networks. They're still important, but they're not vital, while ignoring some of these vital resources that, if they were to get compromised or disrupted in some fashion, would lead to critical losses for the organization as a whole. So finally, this also extends not just to preventative defense, but building out resiliency as well, because we can't always be certain that we will stop every single attack. Setting that as a goal is not only unrealistic, it is quite impossible, which means we must also build into the concept of operations resiliency and recovery. This means not just the ability to restore a workstation, but also when it comes to critical processes within our environment or critical business aspects, can we not just restore a computer, but are we restoring information? Are we restoring configurations and other such items, so that we not only bring up the logical asset, but also bring up things to a known good, known level of integrity after an incident takes place? Part of all this, so we're at ZeefCon. This is where red meets blue, right? Well, that also means that these concepts of trying to focus network defense around organizational value and understanding process dependencies needs to be adequately tested and audited. And the best way to do that is through testing these plans and trying to observe exactly how it is that we're doing when it comes to trying to build out a organizationally specific, operationally resilient defensive planning. So the way we can do this, and doing this through an actual pen test is difficult, but certainly things like tabletop exercises or walkthroughs of incident response and defensive plans, and doing a critical look at things like where our network visibility and where our network defense is enabled, can allow us to try and identify areas where we are weak or where we need to build out greater amounts of detection and visibility. So we can take our defensive measures and our recovery plans and run them against comprehensive attack scenarios that don't just look at, hey, I can get domain admin, but rather attack scenarios that look for objectives like, hey, I want to put your company out of business, or hey, I want to shut your organization down for 7 days, or something along those lines. And how would I go about doing that? Not just what networks would be breached, but what are the critical touch points I would need to compromise or disable that would enable this sort of event. And this allows us to begin identifying gaps or missed vectors as part of our existing defensive plans and building out a more holistic or greater in scope defensive planning that can take into consideration these sorts of scenarios. So yes, something very much like a purple team exercise that incorporates not just your IT personnel, but also the individuals that are responsible for how it is your organization is generating value, whether that's the manufacturing environment, the operations personnel responsible for how the bank runs, et cetera, to try to identify what are those critical items that are necessary for the organization to continue operating. Okay. So to close out, what are my future expectations in this space? So I think this is a fascinating topic, and it's not something that is typically covered from a cyber perspective, because it involves lots of understanding of business environments and how IT networks overlap with more general operations. Well, the thing is that we don't have a choice, because attackers are getting smarter and bolder when it comes to these sorts of operations, and have been doing so going back at least through 2014, and are doing so in a way as time has progressed from there to becoming more targeted, more disruptive, and potentially outright damaging, as we saw with the Abcake strike, such that organizational defenses have no choice but to evolve with adversaries to meet these challenges and to try and build out defense in such a way that we are enabling our employers or the networks that we're responsible for defending to counter these sorts of challenges. So from a defender standpoint, we have to start embracing a mindset where cyber defense is more than just the network. The network is just the medium through which attackers interact with things. We need to understand how information systems control, impact, or enable organizational value creation, and how attackers can take advantage of that to do real harm to the entities that we were responsible for defending. This gives us a wider scope necessary for implementing and maintaining defense, that we need to expand our horizons and maybe bring in different stakeholders than we're used to talking to design defensive planning, establish things like priorities, identifying vital systems, and how it is that our defensive planning adapts to these critical components. In terms of incidents, I don't expect things to get better. In fact, I expect things to get worse. Does that mean that we'll see explosions as a result of cyber? Probably not, because there's lots of other safety controls that come into play. But attackers they're trying pretty damn hard in order to get to this level of complexity and potential damage. But we also see this in things like election security. Multiple entities are attempting to somehow influence or undermine the US election that is coming up in a couple of months. But we even see things like this if we want to go all the way back to the 2011-2012 Operation Ababil campaigns against the US financial system, that we can see these sorts of scenarios playing out in other areas as well that could have significant economic impacts, not just to our own organizations, but even to entire countries or entire regions that are economically interlinked. So lots of possibilities here for attackers to do nasty stuff. So to conclude, as I'm coming up on time here, organization defense is more than just cyber, but cyber is increasingly connected to multiple sources of value. Whereas previously lots of things would have been physical process control only, instead we've expanded networking, we've expanded links to the cloud, to MSPs, and to other organizations, such that we now operate in environments with lots of both internal and external links that produce potential dependencies and potential disruption points that didn't exist previously that we need to be aware of and plan for. Unfortunately, adversaries understand these weaknesses and are attacking them. One example we didn't talk about, but I've kind of hinted at multiple times, is third-party service providers like MSPs are increasingly targeted by attackers, whether as a means of infiltrating their client organizations or as a means to impacting organizations in other fashions. But we need we seldom think about our MSPs as part of our defensive planning, and yet we're highly reliant on these third parties for our own organization's day-to-day operation. So overall, in looking at all of these items, vendors, suppliers, third-party links, but also internal network connectivity and inter-process dependency, defense has to evolve and become more aware of the context in which we're operating, so that we're not just making sure that Bob's workstation in accounting doesn't get ransomware installed on it, but to make sure that the entire organization doesn't fail or doesn't go bankrupt as a result of an attack that wipes out a critical source of value that allows the organization to continue existing in the first place. So these slides will be made available. I don't know where yet. I'll tweet them and whatnot, but I know ZivCon is recording this as well. Here are a bunch of references that if you'd like to get into any of the examples that I talked about or some of the concepts in greater detail, a number of things that I've written, as well as some excellent reports from ESET and FireEye on a couple of these examples as well. But I know that we're up on time, and this is the last talk of the day. Some people are probably burnt out at this point, but if there are any questions, I'm happy to entertain them here. Certainly could hit me up in other areas as well.